Welcome to Nokia 5G Talks, the professional podcast exploring Nokia technologies. Hello, I'm your host, Norbert Tavali, and today we are exploring truly transformative topics that are reshaping the telecommunication industry as we know today. We will start by unpacking the world of Saas products, what they are, how they delivered and operated, and why they are revolutionizing the way we think about the software in the telco space. To help you visualize this, think of Saas products like a public bus system in a big city. The buses are the Saas products. They are designed for different use cases, like the Nokia telco solutions. The company that's running the buses has to design the roads, maintain the fleet, hire the drivers, make sure the on-time service, and scale up if the roads get crowded. All of these while following safety and compliance standards. It's a perfect analogy of Saas products deployed, maintained, and operated in the cloud. And here is a fun fact. If you ever made a phone call or used your mobile data, there is a high chance you interacted with at least one Nokia product in the communication chain, whether it's radio, transport, core, or application. So buckle up for an exciting conversation that connects the dots between the technology, innovation, and the future of connectivity. Hello everyone. We have today with us Gábor and Momo. Hello guys.
Hello.
Hey, welcome back.
Right. So in our previous podcast, we discussed about how the core network service was delivered in the past, how complex it is, and how our Saas automation simplified the deployment with introducing a top-level intent approach. But how this works, how this really works in a real life, how we deploy core Saas today.
Yeah, I can take you with few examples we already had in the past. So our first customers were really exploring how core Saas works, and the first deliveries was mainly experimenting on the market, what can work and what not, and how we should deliver. And to be honest, the secret of the core Saas is that we start as a friendly discussion with the customer, because they are coming to us with their ideas and their plans that something new has to be achieved, mainly some innovation case, or they want to demonstrate something new, cutting edge technology, and the core Saas is the perfect playground for this, because we can simplify the deployment, we can build up new use cases on top of the existing ones, and we can deploy quite easily and fast a core just to play around with it. And the typical delivery starts with a discussion with the customer. They are coming with the use cases. Our architects and engineers are involved in the initial discussions as well. We are sharing our ideas and we are sharing the capabilities of our products with the customer. Then together we decide what they really want and how we should achieve that. And this is the part where we also negotiate the deployment parameters in the so-called CIQ, which then we are using to feed our automation. The automation itself is a back end, but we as engineers are using a front end, so-called service builder, former name network builder, which is a quite interactive GUI where we can select which public cloud to deploy, which account, which region, and actually which availability zone as well. Feeding the data in from the CIQ, the top level intent, we are starting the deployment. And once we click the button to deploy, we sit down and wait a couple of hours to have the core up and running. And once the core is up, then we start the integration. And more or less the integration itself takes few hours as well, mainly because we will need to ask the customer on their side to prepare the connectivity, to configure the networking. And once they are done with their side and we finish with our side, the integration comes up. And on the same day, when we started the deployment and we finished the integration, then we are doing the first tests. And at the same day, the first call tests are succeeding.
I really like the way you summarized all of these steps we're doing as part of the core delivery, but these are all happens in a sunny day scenario, right? It's not always smooth.
Yes, it's a sunny day scenario, exactly. But the main strength in core Saas is that our SREs, the site reliability engineers, are professionals who can troubleshoot quite well and figure out the root cause of the issues. So even in a rainy day scenario, the next day we are ready to make calls.
Maybe just adding to this still before we go deeper into the operations area, is that the already mentioned Service Builder is an in-house built tool that we are using to summarize all that automation framework and tooling that we mentioned in the previous episode, which is, just to summarize it, like a GitOps-based approach, that we are already giving possibilities for the SREs themselves who are actually doing the delivery for the core itself to do final fine-tunings for the service deployments. So when the order comes in, it appears in a modularized fashion. So we are not just doing like a one-shot deployment, because troubleshooting that would be quite complex. Instead, what we are doing is just separating the core into separate modules that can be individually deployed and fine-tuned further. For example, networking is a separate module, the cluster deployment is a separate module, and additionally, the applications themselves separately are individual modules. And you have the capability to, based on the information coming from a CIQ, to add additional information to that as well, as an SRE, with like inside knowledge, because the customer doesn't have to know each and every parameter. This is what we are trying to actually not exposing to them, because then agreeing on each and every parameter would take like months in advance. We already have like a golden configuration set that we know that works, but we still have the option to fine tune at that point. So that is one important thing to emphasize. And the other part is that based on for the rainy day scenario, the tooling itself is also on the UI presents you the view of the individual resource loops for the intent-based automation, and you have actual feedback on the UI itself to actually know which parameter, or sorry, which control loop went right and which control loop that is still reconciling. So as I mentioned, reconciliation is about consistently trying to achieve the desired goal. There could be scenarios that it's not possible. For example, somebody out of IP addresses. Even though the automation works perfectly, it's a resource issue on the hyperscaler end. So for that one, you cannot really do much in the automation itself. You have to reach out to the public cloud provider to actually resolve this issue. But we have these feedback loops built into the system, so this way you can interact with these resources.
Yeah. It sounded like our SREs are the Navy SEAL team or the Marines, and we gave them really cutting-edge weapons like the Service Builder and our automation framework.
That's the point, yes.
Yeah, definitely.
Thank you. What about core operation?
Yeah, once the core is deployed and the customers are trying to start working with them, start their services on them, trying experimenting with it, then comes the operation part, and the SRE team is responsible to operate the network. In the on-prem world, we have Nokia products achieving these operational tasks, but those systems are quite complex, and it was not a wise decision to bring that into the Saas world, because the integration takes too long, it's quite heavy in resources, and also it needs time to integrate all the CNFs, hard to automate. And we had to figure out a solution for that. And unfortunately, we haven't found any solution for that inside Nokia or outside Nokia. What we had was the clear vision how we want to operate the network. And for that one, we had quite good examples with the already existing Saas products, because external tools Saas-like tools were introduced in the Saas world to use for operation. And the clear question was how we can integrate to those existing applications. And we came out with an idea to develop an own solution for that. It's called middleware between the core and between the observability applications. And this tool has been developed by us. It is having the auto-integration feature. So once the core is spin up, we just give the trigger and the tool itself discovers the new deployment, which network functions have been deployed, and immediately it starts to integrate with all of the network functions and tries to collect the measurements and the alarms, the so-called PM and FM data from them, and exposes to the observability tool. This observability tool is a single pane of glass solution, which means that every core Saas deployment can be observed in one application, and we can switch based on which core deployment we want to observe. And of course, this tool is integrated with another tools to have the operation, because itself seeing a dashboard is one thing, but we don't want our engineers to look all the day the dashboards, because they are doing integration, they are doing deployments, they are doing troubleshooting. So there is no time to view those dashboards and figure out if something went wrong. So we clearly need some automation on the operation as well to interact for let's say, for some problems occurring on the network. For example, if some KPIs are degraded or some CNFs are reporting some alarms, then there is an intelligence which can process these kind of metrics proactively and can start alerting. And the observability tool called Datadog is integrated with PagerDuty, which is another Saas kind of tool, exactly for that purpose, to have this intelligent working to detect the anomalies, detect the problems, and to notify the engineers about such happenings.
And also on the topic of dashboards, they're actually using the same data, or maybe a subset of data, because certain data is not interesting for the customer, but we are still exposing part of it to the customers as well. So they have their own dashboard. We have the capability to even customize to their needs if there's a specific metric that they are interested in. And we can provide customized dashboards for them to monitor their own values that they are interested in. Obviously, it's possible to actually redirect such data as well, so they can process it with their internal tooling. But obviously, by default, we are providing a dashboard, so they can have a quick look for the status of the network itself. And again, the important part is that we're using the same technology and the same information for this as well, as for what we are using for internal purposes.
Absolutely. You mentioned an interesting topic, Momo, on the in-house built tools that you didn't find anywhere, inside, outside, or any existing product on the market. So do we have other products? Did we develop any other product that's serving core and that kind of drives to the discussion that is it enough to run the core Saas as it is today, or we need supporting services?
Well, it's depending on, because every customer comes with their own requirement. And out of the box, if we provide the core, let's say for a 5G use case, then our solution can satisfy their needs. But some customers are coming with some special requirements, and therefore we have some surrounding applications supporting the core as well.
I would differentiate between two different types of this custom automation work or additional service creation that we needed to do. One part is when we are actually utilizing third-party tooling, which is not in-house built, but we still need some additional automation that is not available for those tools. For those specific use cases, like managing our Git repository, which is by default is not cloud native, we develop tooling which can actually do it in a GitOps fashion as well as we are doing with the rest of the automation. So we have these types of automations implemented and developed. And the other part is when the actual cloud provider is not giving us enough in terms of compared to the telco requirements that we need, just tying back to the first episode where you mentioned that telco has like stricter requirements compared to regular IT workloads. And most public cloud providers are actually aiming primarily IT. Obviously, we are talking with all the public cloud providers and the major ones to have services and capabilities that are telco specific, but we are still far from 100% coverage, I would say. In these specific scenarios, we still had to develop some things that can serve the need, for example, of a core network, which is, as we previously mentioned, is the most complex one to tackle. One area could be to mention is like DNS. Obviously, each and every public cloud provider has a DNS solution, but DNS is quite a wide range of a topic. And in most cases, it's also a cornerstone of each solution. If you heard that internet went down for 50% of the world, it's usually DNS. So DNS is an important part. And for telco as well, DNS is really important, but there are many features and types of queries that you can do with DNS. A certain amount of those are not supported by default by the public cloud providers. So in these scenarios, we couldn't use their service offering, but we actually had to build a solution for that one. Another would be, which is still tying to the telco requirements quite nicely, is like storing data. There are certain data for telco workloads that you have to store for long term, and there were not enough robust solutions to do this in some cases for public cloud providers. So again, we had to develop something for storage as well.
As we are talking about data, many of the data produced by the core are confidential data, which needs security requirements.
Like CDRs.
Yeah, like CDR, which is the call data records, which has confidential information about the subscribers and the data usage or whatever else. And for those ones, we had to develop a solution how we can store the data and how we can pass over to the customer, because they are using those data to charge the subscribers.
These are very good examples, guys, that you're bringing it up today. And these are exactly the reason why we forced to build mission critical capabilities to support core. And this is what we call common services, right? On top of public cloud, because of various reasons. It can be external, internal, can come from the software side, you mentioned core, or can just come from the infra side, simply because those hyperscalers not really prepared to run and host such a complex workload.
It's also beneficial altogether for Nokia. We are talking a lot about core, maybe a bit biased, but obviously Nokia has other solutions as well. Down the line, I think we will talk about them as well. But the important takeaway here is that these services and solutions that we additionally developed on top of public cloud, these can be reused in other services as well. So the idea here is to have some kind of internal synergy even. So different teams are not developing the same thing over and over again, but actually we can reuse the same approaches in various different areas, not just core.
Like a Lego building blocks.
Exactly.
We put together what is needed and reuse what we can.
Exactly. Thank you. What about the other topic, autonomous networks?
Before we go there, I think what we should discuss is that, okay, we talked about core, but how we can use core itself. So there are certain
use cases,
certain business
Good
cases. And the reason why I would like to talk about this, because this will showcase why we need additional services or in certain cases to be offered to the customers. Not necessarily needed. For certain scenarios or certain use cases, we are already out of the box. Core itself is enough. But for certain customers, it could be that they need something else to supplement their service. So Zoltán mentioned the innovation case.
As I already mentioned, there are customers who want to experiment. They have their own core network running at home, serving several millions of subscribers. But those networks are not really for experimenting, and they even don't want to buy expensive hardware just to build a sandbox. For those customers, the ideal world is the public cloud, because we can deploy within one day the sandbox for them, and they can start play around with it. And they can develop new use cases, they can test the new technologies with it. This solution we are calling, or this kind of deployment, Core Saas for Innovation. And most of our today's deployments are Core Saas for Innovation, because Saas is a new thing. Everyone is trying to taste it, try it, and have some competence with it. And once they have tried it and they decide that, yes, this is a quite nice solution, I'm very happy with it, let's continue our journey together. And there comes in the core Saas for business, which is not a sandbox anymore. It's designed for production. And for production, we can also offer many advantage things like a redundant setup. We can deploy 2 cores together, which gives us the redundancy. So it's feasible for live operations. We can serve live customers with it, or live subscribers, and it is designed to make business.
Two points to this. First, for the innovation cases, Zoltán mentioned that experimenting with your own network is kind of no-go. Most customers usually have like a lab environment, but still messing up a public cloud deployment, which already fully automated, and you screw something up, you can just quickly redo it, redeploy.
Yeah.
Let's go. It's much harder to do it in an on-prem scenario. So that is one portion, but the other portion is that we're already considering 5G as something that is already there, it's done and dusted, let's go 6G. But for many customers, 5G is still only applicable to the radio side. So the radio itself is 5G, but the signaling part that is serving the users is actually still 4G.
Yeah, it's a non-standalone method.
Exactly. And for those ones who actually want to move, for example, to a standalone network where they have the core natively being 5G, it's a nice place for them to start to actually try this service-based architecture, which, again, I think we will touch when we are talking about supplementary services. It's a good place for them to start. As for the business, Zoltán mentioned the redundancy. We're talking about telco requirements, set 2 cores, but okay, we have one core, other goes down, it's nice, but still, regarding the complexity, it's important to understand that this is not just the only way to do redundancy, but even inside a single core instance, you have multiple redundancies built in. So by itself, just a single core is already quite nicely redundant. But if you have like an even higher requirement towards your network, because it's like mission critical, then it's obviously a redundant setup where it's just not about local redundancy, like having 2 workers for the same type of workload, but actually having the second core in somewhere else, like a different country even, makes sure that whatever happens in that country, like a huge nationwide power outage, you still have a core up and running somewhere else to provide an even higher level of redundancy and availability. And one service that we didn't mention yet is core Saas for Edge. We're talking about public cloud when it talks about Saas, but there is like a middle ground between where you have like a service provider who's hosting services in an API-driven fashion, but you are also providing something. So for edge use cases, there are data center hosts and networking providers where we can actually deploy our servers into their own network and then connect that back to the central cloud in public cloud. So for in the edge case, pun not intended, is that, for example, for roaming scenarios, it would be nice to have a user plane function which is handling the user traffic close to the user itself. When you are roaming, especially like internationally or overseas, that traffic is routed back to the home network, which a lot of latency, slow data speeds, and obviously additional cost for the provider itself. What you can do with core Saas Edge is to, as a service, order a server from us. That server gets delivered into the data center on the visited network or the visited country. And then our automation reaches into that data center and configures that edge location automatically end-to-end. And then that one gets connected back to the central cloud. And this way we can distribute the user traffic into places that are closer to the user. This way, making it cheaper and making it's a much better experience for the end users themselves.
Well, it's a kind of similar, exists already in the standard. It's called local breakout. But in our solution, the edge is controlled by the customer. So it's like an extension of the network.
Right.
And that clearly differentiates from the so-called local breakout method.
So we mentioned several times public cloud and public cloud space and security. So what do you think, how we How we tackle the security aspect of running a public cloud, confidential data. You mentioned the common service, the storage, and storing these FMPM or even sometimes CDR data for the customer. How do we tackle the security topic, and what other products it introduces to this picture?
So if you're talking about general, like what we refer to as autonomous networks, these are like supplemental applications that are helping to the core use cases. And for each and every customer, they have a different view or even have a different vendor in some scenarios. But we're trying to offer for each and every area a solution. And we have various autonomous networks products, and a subset of those are also available as SaaS. So this ties nicely in that we have a SaaS-based core deployment, and it's really nice to attach a SaaS-based autonomous network component next to it. What are those products that could be beneficial for such a network? One is AVA energy efficiency, which is about saving energy on the radio side. Okay, we talked about that. Okay, I cannot host a radio in public cloud, right? So it doesn't really make sense at first, but if you think about it, just because you have the core deployed in the public cloud, the radio is still distributed in the very locations that they are running. And supplementing this, we could deploy this AVA energy efficiency product, which then through the core and to the OSS layer can reach into the network, the radio sites, and configure them based on the actual needs. So just an example, so you think about the savings by themselves. So if you are taking like the full amount, 100% of energy use for a scenario, like 10% of that is like transport, 10% is for the core components, and like 80% of that is just the radio. Right. It's a huge amount, especially nowadays. Energy is like a critical resource, I feel. So saving energy is saving money, saving the environment, so already beneficial. And there are certain components in that chain that could be fine-tuned based on the need. Obviously, just like how the electricity requirements or like the need for electricity in the network changes, the same goes with data traffic as well. Overnight, it's usually much lower compared to how it goes during the day. And for those scenarios, via machine learning-based approaches, you can actually predict what would be the load. And based on that, you can even turn off radio sites if needed, or just fine-tune them, change the angle of the radio. And this way, you can optimize the radio itself. And parallel to this, you can optimize the cooling as well. So out of that 80% is like 20 to 30% is just about cooling, heating, and so on.
Exactly.
So again, a huge volume. And based on the similar approach, you can automatically fine-tune the cooling requirements next to the requirements of the radio itself. And this way, depending on the climate of the customer, how energy efficient they are already, or if they are using the latest radio technology or not, the savings could be from like 5 to 20, 25% even, which is like a huge amount of wasted resources. So it's a nice thing to help them with.
It's a very complex ecosystem you're trying to fine tune and control on the
and the SaaS business model fits here perfectly because you can just spin it up. It's like you don't have to buy hardware, etc. You just spin it up as a service. You can try it. If it's beneficial for you, because as I mentioned, maybe for your network you're already optimized, you don't need it. You can just try it, give it a go. After a month or two, you see the savings, and if you see that compared to the service cost is actually saving money as well, other than just saving the environment, then you can go ahead with that one. If you see that you don't really see benefits because you're already optimized, then you can just cancel your subscription and that's it. So it's quite an easy way to save some money.
What about, I know particularly network as code or platform monetization?
Yeah, actually, we have several applications supporting the core, and we have one special application which is really up to the customers to build new use cases and to explore new ways of how to get benefit from the core, especially from 5G core. And that's the data itself inside the core. I mean, data can be a value, knowing about, let's say, customer status or subscriber status or subscriber location, or just have some VIP subscribers where I want to give additional bandwidth or just some prioritized traffic. And for that one, we are using a 3GPP standard network function called network exposure function. And we can expose the core data using the network exposure function. And right after connecting with network as code to the network exposure function, we can get use of the data. So we can program the network, we can send the network commands to modify the subscribers, we can get out the location data, we can get out the subscriber status, we can build use cases where we check the status of the subscribers, and maybe if the subscriber is coming online, then we can trigger some events on top of that. Or maybe we can detect that the subscriber is visiting a sports event and he has a VIP subscription and he wants to see the camera right close to the sport event, maybe a camera on a player, then the network is detecting that the guy reached that location and it automatically triggers extra bandwidth and the capability to connect to that camera and watch body close what's happening. Such kind of business cases can be exposed with using network as code and network exposure function.
This is really awesome. I really like this analogy, this example.
And nicely tying to this is just referring back to the innovation case that we mentioned, that customers are experimenting with this. This network exposure function is like a 5G specific component, so it's only available for 5G. So if you're new to 5G, this is also something that you have to experiment with. And via the innovation cases, it's quite easy to pick up and actually integrate external applications. Now, hidden the complexity of the network itself is just like a regular coder, you can actually program the network or program certain functionalities and reach into certain APIs to gather the information that is needed by you. Just a quick example, for example, in Belgium, what they are doing is actually monitoring a huge amount of traffic, how the people are moving for public events. And this is needed for police, for example, to know that how many people they actually have to send out to the field to actually help the crowd move. And that depends on how many people arrive on that day. And you can get this data programmatically, anonymized, so you don't have to need each and every people. The application controller doesn't know anything about that one because that complexity is hidden by the network's exposure function. But this way you can just, for public safety, it's a really important case, or when you're flying drones overseas to actually monitor like disaster areas. In those scenarios, via this way, programmatically, you can turn on quality of service to make sure that drone gets the priority and not somebody's video download at the time that can wait a second. But for public safety, if for example, if a drone is checking or verifying a fire site, that gets the priority based on this programmized quality on demand.
Very important use case, is really cool. Okay, as a last thought, I brought some quiz questions to you guys. They are very funny. Unfortunately, I need to use my paper, but as I said, they're going to be very funny. So as of 2024, how many SaaS applications does the average large enterprise use? I have 4 answers. A, 12, just email, chat, and 10 different versions of Excel. B, 55, because every department insists on their tool. C, 130, because why have one CRM when you can have 5? And D, 1,000, because IT lost track somewhere around 2080.
Are you expecting an actual answer to this, or?
Absolutely, there is a right.
I say, let's go with the 55.
I go with the C.
And Momo is right, 130. The average large enterprise uses around 130 SaaS applications. That includes tools for HR, finance, marketing, sales, collaboration, and at least 3 that no one knows who owns. And here's the second one. In 2024, how many SaaS companies were estimated to exist worldwide? A, 500, all run by people named Chad in Silicon Valley. B, 5,000, because everyone pivoted from crypto. C, 30,000. Turns out there is a SaaS for everything, including goat yoga scheduling. D, 1 million, including 999,000 that do project management.
I vote for C.
C.
And you both correct. 30,000 estimates say there are over 30,000 SaaS companies globally. If you think of a task, there is probably a SaaS product or 5 for it, even one for managing those other SaaS subscriptions.
Okay, maybe we should provide something on-prem finally.
We discussed today how Nokia Saas is delivered, operated, and maintained, how we build in-house tools and integrate them together to a single solution. We also discussed and explained the autonomous networks and this vast portfolio and how that portfolio and those products enhancing and boosting telco capabilities. What do you think? What's going to be the next turning point on this field?
I think now core SaaS will become more and more strength, and more customers will realize that it's much more simpler for them to go with core SaaS instead of deploying on-prem. So our way would be to deliver what they need. We need, of course, to develop more features and make more robust solutions and more feasible for the core SaaS business. And that will be, I think, a game changer in the next coming years, because more and more customers will find that this solution is a way more better approach compared to the on-prem world.
Thank you.
And just piggybacking on this, obviously the scale of the network that we require now and even down the future when more and more things will be connected to the network, obviously scaling that for each individual service provider is like impossible. Like, for example, this edge location cases that we discussed, that having all those edge locations to serve that latency requirement and throughput requirement is like kind of impossible. So it's like evident that it will be like a separate area of operation, that somebody operates the data center, somebody operates the core, and you can just connect into the separate data centers and automatically deploy things there. So to my mind, it's a question of when and not how, because the how is quite evident that it will be like a service, like a software as a service based approach. The question is when it will be widespread and how we are getting there and how we can get as fast as possible to that direction.
100% agree. It's inevitable. Thank you for joining us today, Gábor, Momo.
Thank you for the opportunity.
And thank you for having us.
A big thank you for everyone joining us today. We really appreciate the time you take to listen, contribute, and engage. Until next time, stay curious and keep exploring. Please follow Nokia on social media and listen to other Nokia podcast episodes. Thank you for listening to Nokia 5G Talks. Check out other episodes exploring Nokia technologies.